All right. So what is a transparent firewall? By default, when you configured the firewall the way we have been doing so far, it is essentially a layer 3 device. What do I mean by that? It's a full-on router. You guys agree? We ran RIP on it, EIGRP, OSPF, BGP, right? It's a full-blown layer 3 device, a full-blown router. So the two interfaces that you have on the firewall belong to two different subnets. So in our case, we had 192.1.20.0 on one side, 10.11.11.0 on the other side. So in terms of connectivity, any traffic that came in over here, yes, it had to follow the security policies, but at the end of the day, it was a routing function. Agreed? Yeah? Yes, please. All right, good. So today, we're going to take a look at how we can take that firewall and insert it as a switch. In the sense that the forwarding will be done as if it's on the same IP subnet, let's say 192.1.10.0. Although it's the same IP subnet, on the two sides of the switch, I will allow a firewall to be inserted in the middle. So this might be 192.1.10 on this side, 192.1.10.0 on the other side. So both sides. It's no longer a layer 3 device, it's a layer 2 device where you're inserting a firewall smack in the middle of a subnet. Essentially a switch with firewall capabilities, or it's a switching firewall. This type of setup is also known as a layer 2 firewall. Good so far? Internally, it is not used as often. Generally, where you use it a lot that I've seen as an implementation is using it as the edge device. There's different mandates, there's different standards that people follow in terms of security, where the first device that you have is the most secure device. So generally, let's say I want to run some type of MPLS from the service provider to your network. MPLS is something that the ASA does not support. But at the same time, they do want firewalling to be done as the first step. So what you do is you put the firewall over here, but don't do any routing. It's a layer 2 firewall like a switch, which is in front connecting the SP on one side and your edge router, which is your normal layer 3 device over here. The reason might be that you want to run or pass MPLS traffic from the service provider to your edge. So in that case, you could not run the firewall over here in the front. You would have to run a router in the front because the firewall does not support MPLS. You get that, Prashant? So this is a very typical implementation that I've seen a lot when you use a transparent firewall. Other than that, not a lot. Internally, let's say you had a subnet and you wanted to break it down, or you wanted to control the flow within the subnet. So let's say internally you had 10.11.11.0 and there were some, clients and servers over here, but you wanted to control access between the clients to the servers. you would put a firewall in the middle, okay? But at the same time, you would break it into two different subnets because it's private, it didn't really matter. So this is what you would do. So on this side, you would say 10, 12, 12, 0. You would renumber the subnetting. So that's what you would do. But you technically could have the ability to put a firewall in that case. Not very often that you would do that, but at the same time, this is something that you would do. Understood, guys? Everybody okay with that? Now, to set this up, how do I make a normal layer 3 firewall and make it work as a layer 2 firewall? Let's see if I have a diagram for it. If not, I'll create one. Go to security. See the transparent firewall one that we have. Let's do this over here. I have a router on the outside, ASA in the middle, a switch, an internal switch where you have router 2 connecting up to router 3. Notice on both sides of the ASA, what do I have? The same IP subnet. On a normal layer 3 firewall, if you try to give the same address to the other interface, it's going to come back and complain that saying that the same IP subnet is being used on another interface. So this is what allows this to happen, is by making it into a layer 2 firewall. Good. We're going to use this topology. I don't think I have it, or if I have it, I don't know where it's at. This is a different one. So we'll just create this one over here. So if I have to create a transparent firewall, actually I might have it over here. Similar. Yeah, there you go. This is the one. I'll fire my devices up. Same topology that I showed you the diagram for. So both sides have been assigned what? So this is essentially a switch. And why did I want to do it? I wanted to control traffic from where? From this segment to this segment. Same IP subnet. Different VLAN, yes. If I had two switches on the inside and the outside, it would be two different VLANs. In this case, I physically segregated that. But let's also talk about what A. Jobert said. Let's say I was doing it on a switching side. I might have one switch over here, and I have router 1, router 2, router 3, all connected to what? To the switch. Port 1, port 2, port 3. All right? This is connected to the switch. This is connected to the switch. This is connected to the switch. Now my ASA is in the middle. I want one of the ports connecting to one VLAN, the other one in the other VLAN. Forget about this being a layer 2 firewall. How would I create this topology? Let's say I wanted to do this. What would I do? I would put this particular port, which is R1, this guy over here, and ASA gig 00, let's say this one in one VLAN, and I would put this port, and this port in a separate VLAN. You guys agree? That would allow me the ability to segregate R2, R3, and the ASA inside into a separate VLAN than the outside VLAN. If I had a physical setup like that, everybody understand that? I want the yeses for this. It's a critical thing. Now, normally, what have you associated with a subnet? One subnet means how many VLANs? Normally, in an environment, one subnet relates to one VLAN. And what I'm telling you guys over here is that, hey, listen, both sides are what? The same subnet. So if you go over here and assign all of them the same what? Same VLAN, there's an issue. What is the issue? When he does an ARP, ARP goes to all the ports on the switch. So it will bypass the firewall. So router 1's port will do an ARP to go to router 2 because they're on the same subnet. Because ARP is sent to the switch, switch will be forwarding that traffic to all the different ports. R2 will respond back because it's in the same VLAN. So they will communicate directly from R1 to R2 because they're in the same subnet. So what I want to do is I want to logically isolate them. And how do I isolate them? And that's what Ajobert was saying, as although they're in the same IP subnet, what I'm going to do with them is I'm going to put them into what? Two different VLANs. So R1 and one of the ports over here. Let's say this is this port over here. These two are in one VLAN. And these three ports, the green ports are R2, R3, and R5, are in a separate VLAN. What's the advantage of doing that now? When he does an ARP, ARP at the VLAN level will only go to all the ports in the same VLAN. So the ASA gets when he sends our broadcast, it will only go to port 4. It enters this port over here on an ASA firewall configured as a transparent firewall. It will allow the ARP to go through. But on the switch side, now this subnet or this particular MAC address is learned from port 5. So from R2 and R3's perspective, if they want to go back, they need to go through R5 to get to R1. So that you're forcing it by isolating at the VLAN level to forward the traffic through the ASA. Everybody understand that? You understand what the significance of putting them into two different VLANs is, although their IP subnets are the same. Yeah? In my case, I didn't need to worry about it. Why not? I have physical isolation. I have physically connected R1 to the outside interface, so there's no way it can get to, there's no physical way of getting from R1 to R2 physically unless they go through the ASA firewall. And that's what I wanted to do with the VLAN isolation anyways. So I've done that like that. On the inside, the internal side, R2 and R3 can talk to each other directly. That's what I want them to do. Good so far, guys? Everybody okay with this? Let's go ahead and implement it then. All right, this is our topology. I want R1, R2, and R3 to be able to talk to each other, but I want R1, the segment that R1 is connected to, and the segment that R2, R3 are connected to be able to, they have to go through the firewall to be able to talk to each other. So let's bring up my routers over here in Secure CRT. There you go, router 1, router 2, router 3, and the ASA. So router 1, I'll do a basic config on it. So R1, we'll do en config t, no IP domain lookup, line con 0, log sing, host R1, simple config, interface E0/0, assign it an IP address of 10.1. I'll also create a loopback over here because I want to run a routing protocol over here as well. And I'll want to run RIP as my routing protocol. It won't be able to communicate to the other two routers right now, but that's okay. I still want to run it so I can show you what you need to do on the firewall to allow routing to work. And for testing purposes, I'm going to enable telnet. Tell me if you guys are okay with this config. Basic IP address config, routing config on router 1. Go to router 1, paste it. Okay. Router 2, which is on the inside, same network. I'm also going to have a loopback, so I'll add a loopback over here, guys, for you guys. So this will be 1.0.0.0/8. This guy over here is 2. There you go. I'll save it in your folder. Three, this is your transparent firewall. So this is what I want to do. So over here on router 2, same type of config. 10.2. Copy. Show IP route, RIP, nothing right now. Why? There's a firewall in the middle between these two guys. Go to router 3. Now 2 and 3 should be able to talk to each other. Oops, my names are wrong. This is R3. And this is R2. So if I do show IP route RIP now, I'm seeing 3. If I do show IP route RIP, I'm seeing 2, and they should be able to talk to each other. All good so far, guys? So this communication working properly. This one, because there's a firewall in the middle, which needs to be configured as a layer 2 firewall, communication is not working, and that's what we want to fix over here. So how do I make this into a transparent firewall? Let's take a look. By default, when you bring up an ASA firewall, when it comes up, you do show firewall. It shows you the firewall mode by default is what? It's a router. Okay, it's a layer 3 device. In this case, I cannot have it as a layer 3 device because I'm inserting the firewall in the middle of a IP segment. Good. So I need to make it into a layer 2 firewall. The command that I use for here is a dangerous command. As soon as they put this command without any confirmation, it's going to blow your running config off. So if you have anything in your running config, firewall transparent will erase it. And this firewall will become a layer 2 firewall immediately. No confirmation asked. So don't just try it, because if you try it, you just blow your config off. Although it doesn't blow your startup config, so if you do it by accident, don't save the config, reload, it's going to reload back to your startup config. So firewall transparent will blow away your running config. Let me put that in your notes. So now what we're doing over here is configuring the ASA as a transparent firewall. By default, the ASA is in router mode. Okay. To change the firewall mode to transparent, you issue the firewall transparent command. This command will blow away your running config. It does not, without any confirmation, by the way. It does not touch your startup config. So just in case you want to recover, don't save the config, so your original startup config is still in place. So the first command is what? Set the firewall mode. And how did I do that? Firewall transparent. Good. So once I do that, the next thing I need to do is configure my interfaces. Now, when you configure the interfaces, some of the things that you need to be aware of. Number one, it still follows that security level name if type of thing. So you still need to give it what? A name. You still need to give it a security level. You do not need to give it an IP address. Why don't you need an IP address assigned to it? The reason is it's a layer 2 firewall. So it does not have interfaces that are layer 3 interfaces. They're all layer 2 interfaces. So this is like a switch port now. Now, what do you assign to a switch port? What's the config on a switch port generally? Let's say I was on a switch. Interface EX/X. Switch port what? Access VLAN XX, right? So if you wanted 2 interfaces to be part of the same VLAN, you would do that, right? Here, you don't do the same thing because technically there are 2 different VLANs, but what you need to do is you need to stitch the 2 interfaces to each other in the sense of what? Any traffic coming in from this interface is connected or can only be connected to what? An interface on gig 01. So any traffic coming in from what? This guy can go over here, this guy can go over here. This is done by specifying what is known as a bridge group. All right. So what I'm doing is over here, I'm assigning this interface gig 01 and 00 and 01 to to the same bridge group. By assigning them to the same bridge group, you basically link them together in the same layer 2 switch. All right, so that's the concept that you need to have over here to connect them up. So under the interface, you don't have an IP address. What do you have instead? You have a bridge group that needs to match on the two interfaces on the firewall that you want to connect to each other. So once this is done, configure the firewall interfaces with a name, a security level, and a bridge group. Good so far? So in my case, my interfaces are gig 0/0. I'll say name if outside. Why outside? This is my basically the untrusted port. What happens to the security level if you put an interface with a security level of any name except for inside? That's it to 0. So I really don't need to do this, but I'll do it for your sake. Because by default, when you do this, what happens? It automatically sets it to 0. And then the only other thing that I need to do is specify a bridge group number. Pick a number. It's, I think, believe between 1 and 500. Pick a number. Let's say 11. Just a number. Whatever number that I picked on this interface, I need to match it on the other interface that is being connected, which in my case is gig 01, which is my inside interface. What is the security level on this interface set to by default? 100. Those things don't change. But now I need to link it up to what? 01. Good? You guys understand this concept? So the link between the two is this number, whatever number you pick. Now, one thing that you need to remember, though, is once you create this, although now it is almost configured as what? Transparent firewall. So I said firewall transparent and set the interfaces. Although it's almost configured, the thing is that's what I'm getting to keep. Now, it does not have a layer 3 interface, any layer 3 interface. If it does not have the layer 3 interface, it does not have the protocol IP, the IP protocol that we use. It's not enabled, so it cannot forward any traffic. It cannot look at an IP packet. You need to enable IP on this firewall. Okay? What they do for that is they give you a virtual interface called the BVI, the Bridge Virtual Interface. For what bridge? What's the name of what's the bridge ID that I used? I used 11, whatever number you're going to use. So I'm going to create a BVI, like an SVI for 11. And you need to assign it an IP address. And because my ASA is in the middle of this subnet, it has to be from where? From this particular what? Subnet. It has to be somewhere in the middle. Now, Keith, this same interface is serving two purposes for me. Number one, it's enabling my IP protocol on the interface, because if you don't do it, it does not have IP enabled on the device, on the firewall. So it's not going to forward any IP traffic. The other purpose it serves is what Keith just asked. What was that? Can you assign it a layer 3 management interface? Now I can manage it by telnetting into 192.1.10.10. So I can set my telnet up to this interface. Because you cannot assign an IP address to gig 00 or gig 01. It's a similar type of concept like a VLAN, Keith, but it's not exactly the same, because generally what happens is you allow free flow between two interfaces that are part of the same VLAN. Here you're connecting two different segments to each other. There's no free flow because you're going to have security, but conceptually very similar to that. And BVI is like your SVI. The only difference is SVI actually routes. VVI does not route. It's just for the purpose of either management to that interface, to that firewall, or, and which is very important, you need to do it anyways, even if you don't want remote management, to enable IP for that bridge group, the protocol IP. Okay, so it is a required step. It's not an optional step. Why inside security level 100 and not security level 0? Take a look at the first lecture along. High security level is what is set up when you name an interface as inside. That's the most secure one. Same zone concept, Jabor, in terms of what? You mean security level concept high to low? Is that what you're talking about? You cannot group group interfaces into zones on a ASA firewall. There's no zone concept over here, not on the ASA. You can do it on a router. You can do it on your, what do you call it? On an FTD, but not on an ASA firewall. It works based on security levels. I'm talking about ASA in layer 3 mode. So there's no zone concept over here. You can create several bridge groups, absolutely. So logically speaking, on the same firewall, I could have another 2 interfaces, let's say gig 02 and gig 03, be part of another set of IP subnets. Just like you can have multiple VLANs on the same switch. So the third step over here is what? Configure a BVI interface to enable IP routing on the interface and allow remote management to the firewall. How do I do it? Would I name it 11? So give it that IP, 10.10, and you don't need to put the subnet because it's a major network. BVI, assign it, and now I have IP routing. Now, what traffic do you think will be allowed to go through the firewall at this point? Layer 2 traffic, our traffic, yes. How about traffic going from this guy, from this segment to this segment? Is that allowed? Let's say this guy wanted to telnet in to 192.1.10.1. Is that going to be allowed? True, yeah, from this guy to R1. It's traffic going from high security towards low. It is allowed, it is inspected, so the return traffic comes in. So the way a layer 3 firewall forwards traffic now, it's the same type of thing. If I did want to allow traffic from where? From outside to inside, what did I need to do? Create an ACL. Those things still apply. So right now, based on this particular config, I should be able to do what? Should be able to go to the inside router, which is router 2, and be able to telnet to 192.1.10.1. Actually, I won't. Yeah, I should be able to because I'm on the same subnet. You guys see that? Who's connected in? 192.1.10.2 is connected in. So that firewall in the middle is basically a switch that's forwarding traffic based on the security policies of the firewall, which is high to low is allowed. Can R1, which is on the outside, can this guy, can he telnet into R2? I just telneted it from 2 to 1. Can 1 telnet into 2? Why not? That traffic is coming from what? Low to high. What if I did want R1 to be able to telnet into R2? I would need to create an ACL, right? Where over here, normally access dash list, outside permit TCP, let's do a host to host, 10.1 to 10.2 EQ, this guy, create another one, permit ICMP, host 10.1 to 10.2, echo. Apply the ACL. I'm doing these basic simple commands again because I want you guys to see these things still work the same way. So normal ACL that I would create to do this. Understood, guys? So at this point, this R1 telnet that did not work now should work. Or if I wanted to ping it, I should be able to ping it because I allowed it. Good so far, guys? What if I wanted to telnet into the ASA? How would I do it? Pass WP Cisco 123, allow telnet from the 192.10.0 network, but from what interface? Inside. So this is a remote management. Let's put that in as well. At this point, traffic will follow the general rules of the ASA. What are the general rules? High to low allowed, low to high blocked. Okay? If you would like the low, no, you don't. It's a virtual interface. It comes up automatically. If you would like the low traffic to traverse through the firewall, what do you need to do? Create an ACL and apply it normally. And how did I do that? I created an ACL called outside permitted TCP from 10.1 to 10.2 for 23, and I did it for ICMP. And then I applied it. Good so far, guys?